Okay, so in this video, let's try to implement reflections. So in the previous one, I came up with a way of interpreting or understanding the math behind reflections, like what changes mathematically in the properties, in the attributes of a array when it has to do a reflection. What happens? And so I thought about it some more afterwards, and I got a few more ideas. So if I look at this ray right here, so it can go around this way, and so when it's going this way, we can imagine its reflection going this way. So if we have the window here, we can imagine the reflection going this way, right? And when we think about this for a second, if we take a look, what we can notice is that so our question is, how can we draw this ray? Well, you've got a few things that you can do. Here you know that you have an angle and you get the same angle here, and so maybe you can use this information to draw the ray here. But I got another idea. If we try to draw this ray but outside of the window, if we extend it here, so for a certain length, and then we draw the symmetrical point. So we take this point and we draw its symmetrical equivalent, where the axis of symmetry is this. Then we get to this point here. So this ray can be characterized by a point of origin, this one here, P1 here, which is a point at which it starts getting drawn, and then here you'll get an automatic angle that will be calculated with this formula, right? But basically I can just have an origin here, P1 here, and then I can use my method called calculate collision point to calculate the collision point starting from here, so starting from here, and then whereas the angle here is going to be the value of this angle, and then obstacles and count and whatever, but the collision point is going to get calculated here, and eventually it's going to land over here, right? And then I just have to draw this line. So let's try to implement this just for the situation where we are looking upwards, and then we want it to reflect this way, because here the axis of symmetry is going to be the top edge of the window, but if the ray were here, for example, the axis of symmetry would be the right edge of the window. So some things would change. But let's do this. So how can we do that? Well, we have our draw method here that we have implemented. So maybe what we can do is, so let me close this. Maybe what we can do is just add some attributes. First, we can add an attribute called, let's see, how can we do this? So we want to know how many reflections we are going to draw, right? So maybe we're going to have an integer called number of reflections. And here in our constructors, we can just initialize it to 0. NB reflections 0. Maybe I can just do that. And that will be all nice and good. Maybe I can do it here as well. NB reflections 0. Okay. Um, let's see. Or maybe I can just do it here. Int n. I'm just going to initialize it to here. N. And then just have to add one here. Okay. So this is how many reflections we want to draw. So this is a base ray, the first ray, doesn't count as a reflection. This is a first reflection, this would be the second, this would be the third, etc. So right now we're just going to work with one. But first let's come up with a method of how we're going to do this practically. So we have the number of reflections. Now what else do we need? Do we need attributes for like the coordinates of the points here? Let's think about this. So we have this ray, and what we're going to need here is the origin of this ray, which is going to be this. Well, not necessarily the origin, but it can be P1. If the origin is actually here, right, so we have our light source here, this works as well. I feel like this works as well. This does. Yes, because the angle here, this angle is actually the same as the angle here. So this works. Oops, my bad. Right, so this works. So instead of using the origin, we can use P1. This is P1. Oops, P1, and this is the origin. And so this is going to be symmetry, like the point that is symmetrical was based on this axis. And so this is going to be, I guess we can call it P1 prime. And for this, we only need P1. Now, when we're going to draw this reflection, we're going to have P1 prime, and we're going to need this, which is given with this operation, calculate collision point. And then that's all we need, because the angle here is just going to get automatically calculated. This is just going to be automatically calculated. I mean, we can just calculate it easily with this formula. And so then when we draw it, we can just draw it this way, but before drawing it, we need to calculate the coordinates of this point. Which, yeah, okay, as I said, it's just calculate collision point. And once we have this point, we're gonna do another reflection if we want to, if we need to, but basically what we're going to need, or what we can do in our case, is something like void DrawReflections. It's going to take an SDL render, const SDL rect obstacles, const int count. Right, it's just going to be basically the same thing, but called DrawReflections. I can put it here. Okay. Now, what are we going to do here? Where are we going to call this? Well, we can call this here, like after drawing our array. And I guess that what we can do is we can just call it here. DrawReflections and pass in the parameters. Okay. Now, what do we do in DrawReflections? So, I suppose that we can do a for loop where I starts off at 0 and until while I is below the number of reflections, then we keep drawing the reflections. Okay. So what do we need first? We need the point of symmetry on P1. So P1 prime. P1 prime. So it's going to be a point, right? So SDL point P1 prime is going to be equal to, let's see, okay, so first of all, how can I do this? SDL point P1 copy is equal to P1. Let's do this because we don't want to change the attribute of P1. We're going to work on a copy. And so P1 copy is, in our case here, going to be this point, then this point, then this point. And so then P1 prime is going to be this point, then this point, then once it goes here, it's going to be, let's see, let's see. No, I wasn't looking at, I'm not looking at the right thing, am I? So axis of symmetry, and then second P1 is going to be this point, symmetry with where's the axis of symmetry, this edge, and then here. So that's how it goes. And then once the ray comes here, it's going to be axis of symmetry with here, so that it draws this way. This goes this way. So basically here what we're doing is we are reinventing optics, right? That's how optics work. Okay, we can do that. And so, but we're going to start off at P1, where P1 is just the P1 of the original point here. But we're going to copy it because we don't want to actually change the value of this attribute. Otherwise, we're going to mess up the representation of the ray. It's going to actually change, and we're not going to draw reflections. We're just going to draw a single ray at a time, but we want to draw several rays at a time. So P1 prime, as a rule of thumb, in our case, so let's just do a single case where we're looking at a reflection with the top edge of the window. So P1 prime is going to have the same x value as P1 copy. As for the y value, it's going to be minus P1 copy y. Because it's going to go from here to here. And the difference in terms of y coordinates is just that it's a negative value of it. Because we're just looking at the top edge here. Okay. So we have P1 prime. We have P1 prime. Now, do we also have this point? This point is P2, basically. But P2, we have it here. P2, we have it here. Wait, why is it doing that? Okay. P2, we have it here, but we cannot access it here. So maybe what we could do is have several attributes, P1, P2, and here, what we're going to do is simply say that P2 is equal to this. Does that sound good? Do we use P2 anywhere else? I don't think so. No, so I should be able to do that, and it's just that here in our constructor we're going to have to initialize some stuff. So maybe I'll just organize this way. And here P2 is going to be null. I think I can do that. No, I can't. I guess I'll just do 0, 0. Because P2 we're going to calculate it ourselves. We don't need to do anything here. We're just going to initialize it because that's what the compiler wants. And the compiler is king. Right. Okay. So P2 is equal to this. And here I'm going to do SDL point P2 copy equal to P2. Okay. Now we can work with P1 copy and P2 copy without changing their value. Alright, so let's look at this. If I run it, does anything happen? Oh, right, it's not going to work because in here in my main file I need to change some stuff here. I'm gonna do 0. Now it should work, maybe. Still not. Takes 2 arguments. So in light, no overloaded function takes 2 arguments. Where is it? Okay. Okay, so now this works as before. Nothing has changed. Right. Race.cpp. Okay. So we have P2 over here. Now let's see. So we have P1 prime. P1 prime, we just got it. Now what we're going to do is do a double reflection angle is going to be equal to what we got here. Just going to calculate the angle, right? Okay, but we're going to change some stuff. The origin here is going to be P1 prime. And this is going to be P2y. So that sounds good. P2x, oops, P1 prime, P2 copy, P2 copy, and P1 prime. Okay, this seems okay to me. So this should give us this angle here, which is, if it's oriented this way, should be a negative value, right? And now, we need to calculate this point. So we have the angle and we have P2. So now I guess we can do SDL point collision point is equal to calculate collision point, where the point starting point is going to be P2 copy, right? And then the angle is going to be reflection angle, obstacles, count. This should work. Okay. And now we're going to draw it. So SDL set render draw color render RGB and A, and SDL render draw line render, and so the points are going to be p2 copy x, p2 copy y, collision point x, and collision point y. Okay. And at the end here, when we are going to repeat the process, we're going to want P2 to go from here to here, and we're going to want P1 prime to go from here to here. So P1 prime is still going to be that. So let's see, P1 copy. So P1 copy is going to be equal to P2 copy. Basically, P1 copy is going to become this value, because so this is going to transform into this, and this is going to transform into this. So that then P1 prime will be equal to this. But in our case, it's not going to be the case, because we're just always doing this formula, which is not true, which is not always going to work. But the reasoning is there. P1 copy is going to be equal to P2 copy, or rather not P2 copy, but or actually, yeah, P2 copy. And P2 copy is going to be equal to collision point. Right. Maybe this is going to work. I honestly have no idea. I feel like it might work. Maybe not. I'm not sure. But let's add a single reflection here. And there was another place where I had to do some stuff. Where was that? Right, so if I run it, what happens? Okay. Now if I do this, so we get some sort of reflection. Right. So some weird stuff is going on here. Some weird stuff is going on here. I mean, it's pretty interesting, but it's not what I was looking for. Okay. So why does it do this? So if we look at the code, what happens in DrawReflections is we have P1 copy equal P1, so this point here, and P2 copy is equal to P2, so this point here. P1 prime is equal to P1 copy X, so P1 copy X is here, minus P1 copy Y. So minus copy, it should be above, somewhere above here. Okay. Reflection angle is going to be, so we have P1 prime here and P2 copy here, and we want the angle between those two. So it's going to be equal to this. Okay. Then the collision point is going to be P2 copy, reflection angle, obstacles, and count. So reflection angle. It seems like something is wrong here. Right, so if I do it this way, this looks right. This looks alright, but it doesn't. Why does it do this? I'm not sure. And then we draw the render line between P2 copy, so P2 copy is here, collision point, which, okay, so for some reason, keeps going here, for no reason. It goes through for some reason, I don't know why. I'm not sure. Calculate collision point, P2 copy reflection angle. And if we look at collision point, right, here it uses P1, but it's not always going to be the same P1 that I'm going to use in calculate collision point. I don't want it to always use this value. So instead of calling P1 here, maybe I should do point start. Right? Let's try doing it this way. Well, now I don't get anything. That's pretty funny. Now nothing is getting drawn. Point start. Calculate collision point. Is it because here I'm above or equal? Maybe I should make it strictly. Let's rerun it. Okay. So, I mean, I'm still calculating this here. So the first spot works, like this spot still works, but reflections doesn't do anything now. What if I do here reflection angle and I do like minus m pi over 4? What if I do this? Is it going to do anything? Nothing. Wow. So, I'm not sure what happens here, what's happening. So, I guess what I can do is print out a few things, like so reflection origin is going to be reflection origin is P1 prime. Then reflection start. And so P1 prime here, and then just give some space, and P1 prime Y. Now let's go to the next line. Why is it doing autocorrect? Reflection start. Right, so I need to include IO stream. Reflection start. And this is going to be P2 copy X, P2 copy Y. And then here I'm going to have reflection collision point X, collision point Y, and then next line. Okay, so what happens if I run this now? Okay, so I got some information here. Now let's change a few things. So I got -1 here. Okay. So if I look at this, so in terms of X, it seems to move correctly, right? Maybe I should also print out the angle. So here, count reflection angle. And here it's just going to be reflection angle. Okay. So if I look at this here, so this point is located at reflection. So reflection origin is going to be 400 minus 300. Okay, seems fair. Reflection start should be 760, so around here, -1. So instead of -1, maybe it should be something else, but okay. Reflection angle. This is something like this is about -pi/4, a little bit bigger than -pi/4, but around that. Let's make it -pi/4. It's gonna be something like this. This would be about -pi/4, right? So the reflection should be like here. And then reflection collision point, it says 734 -1. So maybe the issue here has to do with the fact that we are starting at -1 reflection start. And maybe this has to do with what I changed literally a few seconds ago. Here, if I add this back, what is it going to do? Is it going to change anything? Right, so this is better. But so I suppose that what I can do here is let's see. So point collision is this at first. So maybe what I can do here is when I'm setting P2 copy here, what I can do is if P2 copy, P2 copy X, well, let's do Y in this case. You know what, let's just do not an if, but just P2 copy Y, and let's do +=1, just to see if this fixes anything. Right. So now we are getting what we wanted. It's working pretty well. Right, that's pretty cool. So that's what we wanted. Okay, so the issue had to do with the fact that the reflection was starting at this value here, at 0 instead of 1. So, okay, so the math behind the reflection is working, but now what we need to do is now what we need to look at is, so it works when it's colliding with the top window here, but only with the top window. So now we need to add a way to check where it's colliding on the window at first. Let's just do the window. And then we're gonna have to add, oh god, this is actually going to work pretty well, isn't it? Pretty happy with that. But then, yeah, so we need to find the math for all the types of reflections. Okay, so that's pretty cool. All right. Okay, so how are we going to do that? Well, that is a very good question indeed. So I guess we should do a to-do. And first thing to do would be what should the first thing I should need to do be? So draw reflections. Okay. And so the first thing I'm doing here is I'm calculating. So this is fine. I'm always going to have this. This is fine as well. But now I need to look at P1 primes. First thing I need to calculate correctly is P1 prime. Here I'm only calculating it for this special case where we have the top window. So I guess we're gonna have to create a function. So like define calculate P1 prime. Okay. I guess I can call it this way, and at some point I'll be able to change the name if I feel like it's not good enough. Calculate P1 prime. First step here. And so reflection angle, this shouldn't change. It's always going to be the same formula normally. So I can just keep it in here. Then I'm going to have to do calculate collision point. So I'm gonna have to have a method called something like correct P2 copy, calculate P2 correction. I can do something like that. So calculate P2 correction. Okay. So then this is just going to be the method, so it doesn't change. This doesn't matter. Then set render draw color. Doesn't change, doesn't change, doesn't change. Right. So here I'm not taking into account obstacles. I'm not doing reflection on obstacles right now. I'm just going to do for the window reflections with one of the edges of the window. So I'm gonna have to define these two methods, these two functions. So let's do calculate P1 prime. Let's make it a private method, and P1 prime. Let's just make our method return a point. Calculate P1 prime. What do we need? We need the original P1, and then we need some information about which edge we are colliding with. So we're gonna need P2, right? So we need P1 and P2. So P1 copy and P2 copy, we need both. So this is going to take SDL point P1 copy, or rather start point, and SDL point end point, right? Let's do it this way. And so we can make these const, because why the hell not? Okay. Can this method be const? So I keep thinking about the wrong things, you know, like I can't focus on the right things, but can this be const? I feel like it's not modifying anything. Yeah, it can. Okay. And so this should be const as well. P1 prime, calculate P1 prime should be const. Okay. Now I'm just going to take this and define it under here. Okay. So let's see. So far we have this, but instead of having this, what we're going to want to do is just do SDL point P1 prime equal to calculate P1 prime, and start point is going to be P1 copy, and here P2 copy. Okay. So now what do we do? So let's remember, we're gonna follow a different logic based on which edge we're colliding with. So we're just going to look at the coordinates of P2 copy. So let's determine first if we are on the left edge. So if P, so endpoint X is below or equal to 0, then that means we're on the left edge, right? So the symmetrical point is going to be here. So what we're going to do is, so here we're just going to first to do SDL point result, or rather P1 prime. Let's make it I don't know, like 0 0. Why not? Just to initialize it. And then P1 prime, or actually let's make it start point. It has to be start point, right? P1 prime is just going to begin here, and based on where we're colliding, it's either going to be here or here, but it's going to start off as a copy of this point. So P1 prime X will be equal to minus P1 prime X. Now, else if endpoint, now let's do the right side, is below or greater or equal to window width, then P1 prime X. Let's see. So if we are here, P1 prime is basically going to be here. What is this distance? This distance is window width minus P1 prime. So we need to add 2 times this distance. P1 prime X is going to be equal to 2 times window width minus P1 prime x, right? Or rather, it's not that it's going to be equal to 2 times this, but it's going to be plus equal, because we're going to keep this value, this distance, and then we're going to add this 2 times. Is that right? Does it seems okay to me. Now, else if end point, now let's do for the y coordinates, below or equal to 0, then p1 prime y is we're just going to change the sign of p1 prime y is equal to minus p1 prime y. Else if end point y greater or equal to window height, then p1 prime y is going to be equal, so I think it's going to follow the same logic here. We want it to go here, and this distance is window height minus this, so it's going to be the same logic. Or actually, instead of copying it, let's just do 2 times window height minus p1 prime y. Okay. And I guess here we can just do return p1 prime once we're done here. Okay. This seems like a fair deal. Okay. I think this is going to work. So, okay, now we have this. Now we're gonna have to do this. So P2 copy, maybe I can do it 2 in 1. Here we're setting P2 copy, right? So maybe what I can do here is ask for not a const value of this, we're gonna ask for a pointer. Right? And so, sure, I can do that. SDL point. Or right, it's what am I doing? Should be no, still not. Or maybe I guess just I'll have to use an arrow here. Okay. Yeah, okay. I can do this way. And I suppose that here I'm gonna have to make things a little bit longer, so up. I'm gonna have to do this for every single one of them. Okay. Because I'm gonna change the value of the endpoint at the end here, so okay. And so here what's going to change is that endpoint, so in this case where we're on the left here, endpoint x, let's set it to 1. Here endpoint x, let's set it to window width -1. Here endpoint y is going to be equal to 1, and here endpoint y is going to be equal to window height minus 1. Okay. So I guess this made it a 2 in 1. And so reflection angle, is this going to change a lot of stuff or not if it's 1 pixel? I guess it's going to change some stuff, but let's see if it works this way now. So P2 copy plus equal 1, don't need it anymore. Is this gonna work? Reflection angle, collision point, calculate collision point with P2 copy. This should be fine now. Okay, so what happens if I run this? Does it work if I run this? Okay. Okay. Let me cook. Let me cook. Now, let me cook. Okay. Okay, I think I cooked something here. Oh my god. Did I just cook something amazing here? I think I cooked. And you know what? Let's be ballsy. Does it work? Does it work perfectly or not? Let's do 2 reflections. God, I'm a little bit scared. Oh my god. I feel like it's working, isn't it? I mean, yeah, I think it's working. It's working, isn't it? Oh my god. It's actually kind of working. Wait. Oh my god. It's actually kind of working. Jesus Christ. This is amazing. Okay. So, I mean, the math behind what I did here is not perfect because I'm, again, losing some information. Wait. I'm losing some information due to this and reflection angle being calculated after modifying P2 copy. So I guess what I should do, and I'll correct it, is that I should calculate reflection angle in this method before modifying endpoint 1 here. I mean endpoint x or endpoint y. But I'm not losing a lot of information, right? But I'm losing some of it because I'm changing the position by 1. So, wow, okay, this works. Now what if I do like literally 5 reflections? The console is going to go crazy, but right, I mean, it's technically working, it's just that wait, am I doing like is like a Fourier transform or something, you know? This is honestly pretty cool. Wow, this is working really well. Oh my god. This is actually so cool. Okay, well, it's working, I guess. Okay. Okay. Now, next step is, okay, let's just correct the thing here. Let's do it right now before I forget about it. So I want to calculate the angle before, and instead of doing that, here I'm just going to call it calculate, let's see, calculate reflection. Let's just call it this way, honestly. calculate reflection, and here I guess what I'm going to do here is just that, then that, double reflection angle, and then reflection angle. I'm going to pass it here. And so here I'm just going to do double ref RA angle. Let's just do it this way. And so calculate reflection. Not the best name, I'm aware, but double RA. Okay. So now we passed in the reflection angle, and basically, so the formula is this one. This doesn't change. But let's do it here. So RA is equal to STD A10, and so the origin is going to be start point, end point, end point, but it's going to be an arrow instead because it's the address that we're getting. And this is going to be start point. Okay. Right. So this line, we're just going to copy it here. Does this still work? Did I do something wrong? Okay, I did something wrong. Did I do something wrong? Oh, right. This should be P1 prime. Okay, we are back. And oh boy, is it working well. Oh my god. Right, so sorry about all this information displaying. I'm going to remove this right now. This as well. And now let's be crazy and just see what it's like having 50 reflections. This is going to go crazy. Can I even run this? Okay, look. Okay, it's crazy. What if I move it here, like? Right, so I can't even display all the reflections because I don't have enough. I need to do the reflections on the obstacles if I want this to work correctly. Okay, well, I mean, honestly, this is working pretty well. So I'll leave it at that for now. And in the next video, let's do so the reflections with the obstacles, with the rectangles. Okay, so thank you for watching and see you in the next video. Goodbye.